This is Team 8852, the Rockettes, and this is our CubeSat Final Challenge.
Our team consists of Meghna Arun, Subiksha Bhaskaran, Sophia Wang, Ameya Srinivasan, and Shruti Devraka. For our final project, we decided to take an analysis of infrastructure damage in communities before and after a hurricane to see how it impacted them. Our design includes buildings made from Legos with different colors that signify different levels of damage done to the buildings. The red indicates the original intact rooftops of buildings. The yellow signifies damage done to part of the roof, and the blue represents buildings which have been completely destroyed.
Our CubeSat aims to calculate the percentage of each color present in the images before and after the hurricane, and then report it back to the ground station with data from each photo. The collected percentages could then be used to make an analysis of the extent of the damage done to the communities by the hurricane. We use a Python code which takes into account the RGB of each image and outputs the percentage of each pixels of each color.
When conducting our final test, we use the CubeSat to capture the before and after pictures of the community and then collect the final percentages from the images we took. Our initial percentages are roughly 9.6% before, and afterwards there was 3.6% of intact rooftop, 3.8% of damaged rooftop, and 1.1% of destroyed rooftop. However, there is a percent error to take into account when looking at our results. The guidelines we set for each color, or in other words, the RGB limits for each color, could be one cause for the error. This would lead to an incorrect result when calculating the percentages. Another cause could be the resolution of the camera and the colors it detects when scanning the image. For example, a pixel with 55% of red and 45% of blue would be considered as a fully red pixel, throwing off the accuracy of the mission and the results. So a higher resolution with smaller and more pixels would produce better and more accurate results.
When considering real-life applications of our model, we understand that our model has limitations associated with it. In reality, the colors of roofs would not always be the same, and therefore we would not be able to identify the damage in the same way. Instead, if a CubeSat was in flight, it would be able to detect damage by analyzing rooftops prior to the hurricane and then comparing it to after. The technique used to identify the rooftops and the damage may also need to include shapes of the rooftops before and after, and also include a wider, more complex range of color.
Our method would produce more accurate results in a community that was mass-produced, where the roofing is all the same color. This would mean that any variation in the roofing color due to damage would be more easily identified than if it was a community of houses with different roofing colors. The CubeSat would need to identify any debris from infrastructure and cross-examine the two pictures to see whether or not the roofing looks the same. If it doesn't look the same, it can calculate the amount of debris and calculate the percentage of damage done to the community. Theoretically, a similar approach could be taken when trying to make an analysis for power lines and other similar disaster aftermath situations. Using the CubeSat at night, along with an intensity filter, could help to identify the areas of a community that do and do not have power, as the light would be isolated in the image and could be easily detected by a program since it scans for color. The information collected could then be used by different organizations and the government for providing relief to communities and knowing how different areas were impacted by the disaster.
When we tested our flight mission, we had issues with time, planning, Bluetooth connectivity, and the coding or programming aspect of the project, specifically with identifying the colors. We felt that we could have done better with planning out our schedule for building the CubeSat, which is even more important when we are actually building a real one. The issues with Bluetooth connectivity were also important to resolve as they serve as one of the main methods with communicating with the ground station. To wrap it up, our initial prompt was to make a CubeSat that focused on natural disaster relief, whether it be damage on infrastructure, flooding, or power outages. Our team decided to focus on the infrastructure. Using our code to calculate the amount of damage done to a community, we were able to create a mission that works with an 11% margin of error, meaning that it works with an almost 90% accuracy. Through this challenge, we learned a lot on the uses and development of a CubeSat and how it is used in real life. Because of the disaster relief prompt, we as a team were able to develop a greater understanding of how a CubeSat would be able to communicate with the ground station to relay important and urgent information to the general public. Lastly, typically with CubeSat missions, they would be vital in ensuring the safety of others while helping to continue daily operations within the communities by helping provide important information. Thank you for watching our presentation.